Hello again, this is Randy, KJ7WLT, and this video is a real quick overview, kind of a whirlwind tour of some basic ideas and terminology that'll be important for the technician class license. It's good if you get familiar with some of this before the class starts. So these slides, some of them have a lot of words on them, but hopefully you can come back and read them at your leisure in a little more detail. But I wanted to introduce some basic ideas. So for radio communication, the main things you need are a radio and an antenna. And often the transmitter and the receiver are combined into a single unit called a transceiver. And sometimes the antenna is directly connected to the radio, as in this little handheld radio. You can pick these up for about $30 on Amazon, ham radios that work on UHF and VHF frequencies. Sometimes you want to replace that antenna with a better mag mount antenna, for example, so then a feed line would be used to connect the two. Or if you have an antenna out in your backyard or on your roof, there would be a feed line connecting them. Mag mount antennas are often used on cars for mobile operation, but people also use them at home or out in the field as a better antenna for a handheld radio, for example. And we usually put it on some sort of metal plate, not just so it sticks, but also because the ground plane that provides is very important in turning this type of antenna, which is a half dipole, into something that acts more like a full dipole by reflecting waves at the surface. So how does a radio work? Well, when you tune a radio to a particular frequency and start talking into it, the transmitter generates an alternating current at that frequency roughly that's oscillating very quickly, typically millions of times per second or megahertz levels. And then rather than producing a pure sine wave at that frequency, it modulates it somehow in order to encode information. We'll talk more about that later, but that modulation gives us a signal that has a slightly wider bandwidth than just a single frequency, but it encodes the information, and then that signal is sent to the antenna, which causes electrons to move up and down very rapidly, millions of times a second, in the antenna, which in turn generates an electromagnetic wave that propagates away from the antenna in all directions. This is just showing the wave propagating in one direction, and that wave consists of an oscillating electric field that's aligned with the direction the antenna is pointing. That's the polarization of this wave, and a perpendicular or orthogonal magnetic field that's oscillating in the perpendicular direction, and it's propagating in a third direction, potentially towards another radio. And when that electromagnetic wave passes by this antenna, the oscillations in the electric field cause electrons to move up and down in this antenna, and if that oscillation is sort of in a range of frequencies that this particular length antenna is able to pick up, which is related to the length of the antenna and how that relates to the wavelength of the wave, then those signals get propagated into the radio. And then on the receiving end, there's a very sophisticated tuning mechanism inside that consists of an electric circuit that typically consists of capacitors and inductors, which you'll learn some more about how you can put those together to get a tuned circuit that picks out one particular frequency or a very narrow bandwidth around the one particular frequency that you have tuned the radio to, and then it demodulates the signal that it's receiving and turns that into sound, for example, if it's a voice communication. Although there are also filters in place in most radios, in particular if there's no strong signal coming in and it's mostly just static coming from sort of random signals, then you can set it so that it doesn't produce any sound from the speaker until it receives a strong signal. That's what's often called squelch. And you can also set things to have what's called a tone squelch, so that it only plays loud signals, strong signals, if they're accompanied by a particular tone that's used to sort of differentiate information coming from one radio from what might be coming from other users who are using the same frequency nearby, but whose transmissions you don't want to be hearing. So there's a lot that goes into sort of transmission and reception of radio waves and the propagation in between that we'll talk about in much more detail in the class. What frequencies should you use? Well, there's several different amateur radio bands that are used by ham radio operators. And they're often referred to either by the frequency or by the wavelength. Those two concepts are related by the speed of light, which is about 300 million meters per second in a vacuum, somewhat slower in the atmosphere or in metal, but roughly that speed. And so, for example, a frequency of 150 megahertz corresponds to a wavelength of 2 meters. And so there's something called the 2-meter band in ham radio, which doesn't actually include 150, but it goes from 144 to 148 megahertz in the VHF, or very high frequency part of the radio spectrum. There's also a 70-meter band up in the higher, ultra-high frequency band of the spectrum from 420 to 450 megahertz. Going in the other direction, there's much longer wavelengths, 20, 40, 80 meters. There's ham frequency bands that cover all of those possibilities down in the HF, or high frequency band. If you go to shorter wavelengths, there's also ham radio bands in the centimeter scale wavelength. These are gigahertz frequencies, billions of oscillations per second, and microwave frequencies are often used for digital communication. Wi-Fi routers, for example, use microwave frequencies in a slightly different set of frequencies than what's been allocated for ham radio operators. So the wavelength determines the size of the antenna needed. So as I mentioned, this sort of antenna, or the mag mount I showed in the previous slide, are suitable for the UHF and VHF bands, but would not work at all well for 20, 40, or 80 meter radio waves, for which you'd need much longer wires or fancier antennas of some sort. And there are many different types of antennas that have been developed over the years, and we'll talk about a number of those in the class. So different frequencies are also used for different purposes. The UHF and VHF is often used for local communications around town, talking to other people in Seattle, for example, especially if you use repeaters, which I'll talk about in a moment, which allow you to reach people in a much broader area on UHF and VHF. But they're not good for talking to someone on the other side of the country or in South America. For that, you need to use longer wavelengths, the HF frequency bands, for long distance or DX communication, because those waves dissipate much less quickly, and they're also bent by the ionosphere, the portion of the atmosphere where gas is ionized and there's free electrons moving around, and they interact with the electromagnetic waves and make them bend back down towards Earth, so that radio waves can come back down thousands of kilometers away from where you're transmitting potentially. Electromagnetic waves also bounce off of buildings, mountains, the moon, and so sometimes that can be very useful if you're trying to reach someone on the other side of a large building. Maybe you can bounce your radio waves off of another building to get behind the one they're hidden behind. But sometimes it's also a problem. There's what's called multipath distortion, where you're getting not only the primary signal, but reflected signals from one or more reflectors, and those can combine together in ways that may distort the signal. The very short microwave frequencies are great, as I mentioned, for packing lots of information into digital communications in particular, but they typically require a direct line of sight, and microwaves are absorbed by moisture, as we know from microwave ovens. That's how they work. They take the energy out of the microwaves. So things like fog or vegetation have a big effect on microwave propagation. Okay, I mentioned modulation. If we have a radio frequency signal at some frequency, we don't want to just send that signal. We want to encode some information in it. How do we do that? Well, one of the earliest ways of doing that was to use Morse code, where we just turn the signal on and off, and turning it on for a short amount of time was a dot, turning it on for a longer time is a dash, and you could send messages by encoding the information in Morse code, for example. That's still actually a very popular mode these days. That mode is the mode that's used for transmitting is called CW, or continuous wave, but CW is also sometimes sort of synonymously used with Morse code, since Morse code is typically the only code that people actually transmit with CW. If we're looking at audio signals, then we might take the pressure waveform that the microphone picks up, which has the audio signal in it at a much longer wavelength than the radio waves are, and use that, the envelope of that audio signal, to modulate the amplitude of the radio wave signal as indicated here, and that's what gives amplitude modification, or AM radio. Another possibility is frequency modulation, which is shown at the bottom here, where this same signal, rather than modulating the amplitude in FM propagation, the amplitude is kept the same, but it's the frequency that's slightly varied within the wave to indicate whether the signal strength is large or small. And there's single sideband is another mode that you'll hear about, which is a form of AM modulation, but that reduces the bandwidth by having to only send half of the information, basically. And then for sending digital information, there are many different digital modes that we'll get into a little bit, where you try to send bits, but possibly compress many bits into a single symbol that can be sent as one particular tone, for example, on the radio. And those digital modes often have error correction built in, so they're more robust to noise in the atmosphere. I mentioned repeaters. So the idea of a repeater is that if you have a small handheld radio, you might not be able to talk to somebody else directly on it if they're far away or maybe behind some obstruction. But a repeater is a radio that's set up with a good antenna and hopefully in a good location, like on the top of a hill, so that it can pick up weak signals from all around and then retransmit them on this good antenna at much higher power than a small radio has. And so it can reach much farther out. So there are lots of repeaters around the Puget Sound area, for example, that are widely used. But to use a repeater, you have to know how to program your radio so that it transmits and receives on slightly different frequencies, because the repeater has to listen on one frequency and then retransmit on another. You also have to transmit a proper tone, one of these tone squelches that I mentioned, because the repeater is only listening for signals that have a particular tone assigned to that repeater, and it ignores everything else. And you have to know the proper etiquette for using a repeater and interacting with other people, because some of these repeaters are used by thousands of people in the area. One of the big networks of repeaters in the group in the area is called the Puget Sound Repeater Group, PSRG. They actually have not just one antenna, they have about a half a dozen antennas going from Lake Forest Park in the north to Cougar Mountain near Issaquah in the south, and they're all linked together on the internet so that someone talking in North Seattle who can reach the Lake Forest Park repeater antenna, that immediately gets sent down to Cougar Mountain and is broadcast in such a way that people down in Issaquah can hear it. So the entire region is kind of linked by this PSRG network. And what you see here on their webpage is that the frequency you would listen to is 146.96 megahertz, but the one you have to talk on is offset from that by 0.6 megahertz, and you have to use this particular tone to be recognized by the repeater. Now, one thing people do on repeaters, and sometimes also in simplex mode, where you're just talking directly to other people rather than through a repeater, is to have radio nets. A net is just a collection of hams who are all trying to talk to one another on the same frequency at the same time. And there are many different types of nets. There's regular social nets, for example, on the PSRG repeater. There's 3 of them every day of the year, 9 a.m., noon, and 9 p.m., where people just get on and talk for a couple minutes about whatever is on their mind. There's nets related to particular topics of conversation. There's a maritime net around the Puget Sound area. There's astronomy nets, various other things. There's events that are set up for, or nets that are set up for particular events, like the Seattle Marathon uses a lot of ham radio operators to keep track of people and what's needed at some of the water stations and whatnot. So there would be a special net set up for that. There's emergency response nets. If there's a hurricane or an earthquake someplace, there's often one or several ham radio nets set up to deal with that. So usually these nets have a net control operator who kind of manages the traffic and whose turn it is to talk next. But to deal with a net effectively, you really need to know the rules and the best practices. So we'll talk about that as well. And by the way, if you want to listen to the PSRG nets, you can listen to them on a radio if you have one. You don't have to have a license to listen, only to transmit. But even if you don't have a radio, you can listen on Broadcastify, which is a web page that allows you to listen to lots of repeaters around the country and also other kinds of radio, police and fire radio and railroads and various other things. This particular link would take you, I think, to the PSRG repeater. So again, this was a lot of material. Very briefly, just to give you some idea, you probably have dozens of questions now about details, and the exam has dozens of questions about the details. So that's what we'll be talking about on Saturday and Sunday in this 2-day course. And look forward to seeing you all there. Again, if you have a chance to do a little studying in advance and get more familiar with some of these terms and concepts, hamstudy.org is what we recommend for that. And our goal again is to get you through this exam. And so here's one question that we'll go through. We have a lot of slides like this where we show a question, the correct answer, and then maybe a hint. This is one you should now be able to answer. And by the end of the weekend, there's another 400 or so that you should also be able to answer. So look forward to seeing you then. And take care, 73.